last lecture, we concluded by looking at operators, where we looked at the various operators, and then we ended up looking at expressions, variables. We looked at data types and all that. Now, in this lesson, we're going to introduce ourselves to what we call control statements in C. Control statements in C. When we talk about control statements in C, what we are trying to basically say is that as you write programs or as you write codes, there will be some parts of your codes over the time or from time to time that would have to run based on certain decisions or certain conditions. Now, these decisions or conditions is what we term as control statements. So control statements, when you take any C programming language or when you take every program, be it C programming, C++, control statement is more like the heart of the program. You would realize that most programs control statements would take about 60 to 70%, if not more than that. And as a programmer, having a good command of control statements is very important. This makes you a versatile programmer. Now, if you would recall some of the examples we looked at earlier on, almost all the codes that we executed, they all executed sequentially. That is from one line to the other, okay? But there are situations where you would need to execute based on a certain statement or condition. That is where we would use control statements. There are also instances where you would have to execute a certain statement or a set of statements repeatedly. That as well is the use of control statements. So let's look at what we are going to be doing today. At the end of this particular chapter, even though control statements has a lot of subtopics, it is expected that by the time we are done with everything under control statements, you as a student will recognize the importance of control statements in programming. You would be able to know how to use the if else, and switch statements to execute codes based on some conditions. You'll also be able to apply while, do while, and for loops for repeated execution of codes. Then you utilize what we call break, continue, go to control the flow of loops and some conditions. So basically, these are objectives for this particular unit, control statements. Now, what are control statements? Control statements are divided into three categories. But like I said earlier on, control statements are used to execute functions based on a certain condition or a statement. Control statements are divided into three. That is decision statement, looping statement, and then jump statement. These are the three categories of control statement. Now let's look at the decision statement. When we talk about the decision statement, we are basically talking about statement that is condition-based statement. It defines single or set of conditions that must be satisfied before a certain statement can execute or a group of statements can execute. So let's take, for instance, you have a bank account. You go with your ATM card, which is your Visa or MasterCard, to the automated teller machine to withdraw money. The teller machine would only allow you access into your account when you know the PIN to your card. So it is based on that condition that the teller machine will allow you entry into the account. Then, based on what conditions you set, for instance, maybe you are withdrawing money, that is the only time the ATM will give you that, will execute that and give you money. Okay. This example of situation is mostly handled by decision statements. Decision statements. Decision statements can also be termed as conditional or branching statements. Decision statements can be termed as branching, or conditional statements. Now, in decision statements, we will look at the simple if statement. If this happens, then what should happen? Then we'll look at the if else statement. If this happens, this should happen. Else, if it does not happen, this should happen. Then we have the if else if statement. So you would have multiple conditions you would want to check. And if none of these conditions are met, then another statement would have to be executed. Then we'll look at the nested if else statement. That is where you have another if else statement embedded within an if else statement. Then we'll look at switch and case. There are instances you would have to switch from one case to the other, not necessarily switching in a chronological order. So these are the decision statements we'll be looking at. Now, what are looping statements? Remember, we said there are three categories of control statements. That is the decision statements, which is also called the conditional or branching statements. We also have the looping statement. Now, what the looping statement does is that it defines a set of repetitive statements. These statements are repeated with the same or different parameters for a number of times. So this is where we are able to do iterations, repeat something more than once or more than twice. Now, in programming, there exists situations where you would have to repeat a single or multiple statements till you meet a certain condition. So, for example, there is a directory with files, and you are to write a code to read the files in the directory. What this means is that you're going to be reading page from page, or page from page to page. And this means you are going to be repeating yourself, or the code would have to repeat itself by reading different pages at every given time. And this is where we use looping statements. Now, looping statements are also called iterative or repetitive statements. There are three types of looping statements that we would normally use in C programming. And these are the for loop, the while loop, the do while loop. So take note of these three looping statements. Now, the third type of statement, as we mentioned earlier, that there are three categories. The first one being the decision statements, the second one being the looping statements. The last one is the jump statements. And the decision, which is also termed as the conditional statement. Jump statements provide unconditional ways of transferring control from one part of the program to the other. And in C programming, there are 3 jump statements that we would look at. So the first one is the break. The second one is a continue. And the third one is the go to. So these are basically a brief introduction to the 3 control statements. Any questions so far? I would prefer you never turn your videos on, okay? Because we don't need them for anything. Any questions so far? If you have a question, just raise your hand using the raise your hand icon or the raise icon. If there is no question, you can just give me thumbs up using the react, and then we can proceed. So any question? I take it you don't have any questions, so I can go ahead. Now let's look at the if statement. The if statement allows us to select an action based on a certain decision. And it gives you, the programmer, some control, or it gives you the opportunity to take control over a piece of code. It could be execution of a code based on a certain condition or a certain input that would be entered into the code. So with the previous example, when you're using your ATM card or your Visa or MasterCard on the ATM, you enter your card, and then based on your PIN, access is granted to you. This is a typical example of how an if statement is used. If the PIN is wrong, it means you will not be given access. So in the if statement, it behaves in such a way that if the condition is met, then a certain task will be performed. And it is used to compare things and take some action based on the comparison. And if you recall, our usage of relational and logical operators. Logical operators and relational operators are used mostly when comparisons are supposed to be made using if statements. So we can say that if statements are also capable of performing actions based on Boolean expression, which is either true or false. Now, since I have mentioned a Boolean expression, it is only necessary that we understand what a Boolean expression is. Now, any C expression or any expression that evaluates either to be true or false is what we term as what? A Boolean expression. But in C programming, however, there is nothing like the concept of true or false. we don't have that value. In C, we would normally represent true with a non-integer or a non-zero integer, and then we'll represent false with a 0. So in C, we represent true with a non-zero integer, and then false executes or evaluates to an integer, it is considered a Boolean expression. If an expression evaluates to an integer, it is considered a Boolean expression. It is considered a Boolean expression. Now, let's look at how we write a C statement. Let's look at how we write a C statement. Sorry, an if statement. Let's look at how we write an if statement. Now, from what you see here, you would realize that on the right-hand side, you have if into bracket, Boolean expression, then a brace is opened, and then the body of the if is also written with a closed brace. So this is the syntax for writing the if statement. That is if Boolean expression evaluates true. Then the statement inside of the if is executed. However, if that Boolean expression is not evaluated to be true, then it will skip what is within the body. So that would not be executed. So let's further explain this or understand this in terms of a flowchart. Now, with this flowchart, you would see that with your basic understanding on how flowcharts are drawn, you have an input, and then there is a Boolean expression. Now, once the Boolean expression is evaluated to be true, then the body of the if will be executed. And then whatever is there, the statement of that the if will be executed. Now, when it is false, what happens is that the body of the if statement or the body of the if cannot be executed. So it will skip that execution because the expression evaluated to false or a 0 in this case. Now let's look at an example of a C program that illustrates the usage of the if statement. So here, this is a program to check if a person is eligible to vote or not. So as usual, we start with our preprocessor directive, #include stdio.h, int main. And since we are going to be looking at the age of an individual to determine if they qualify to vote or not, then we would have to declare our variable. And in this case, since the age is an integer, the data type integer comes before the age is declared. So you have int age. Now, we would need some input into the code before we can tell whether the individual or the person is eligible to vote. So printf enter your age gives a prompt on the key on the window, and then through the keyboard, the age is entered. Then scanf would help us to read whatever integer has been entered for age. Then this is where we go to execute the if statement. So here, by the use of relational operator, you have if, and then within the bracket, the relational operator is used to check if the age that was entered is greater or equal to 18, because in Ghana, the eligible age or the age that makes someone eligible to vote is 18. So if it checks and the age that was entered is greater or equal to 18, then it will print the body of the if. That is, printf, you are eligible to vote in Ghana. And this is how the if statement is executed. Now, someone would ask, what then happens if we are not able to execute, or if the age is less than the voting age? That would then lead us to another statement. But in this case, we can also have single versus compound statements inside the if. So in this case, you have the if single statement like we have executed already. We can also have multiple or compound statements within the if body, which would be executed based on the Boolean expression. So you take note of that. Now, like I said earlier on, what happens if the Boolean expression or the input into the code gives us a false instead of a true, so that the statement will be executed? And that leads us to the if else statement. So simple if works if some condition is true, then a certain task has to be performed. If it doesn't specify what to do if condition is false. However, in order to be a good programmer, you would have to think both ways. False and then true. So this leads us to what? The if-else statement, which is basically an extension of the simple if statements. That is, if the condition is true, execute a certain task. Otherwise, execute another task or perform another task. So let's look at the syntax for the if-else statement. So you have the if with a Boolean expression. Then we have the body of the if. Now the body of the if would only be executed if the Boolean expression is true. However, where the Boolean expression is false, then the body of the else would then be executed. So if Boolean expression is true, then the body of the if is executed. If Boolean expression is true, the body of the if is executed. However, if it is false, then the body of the else is executed. So take note of that. Let's take a look at how a flowchart of if-else is done, or the flowchart of an if-else, and how this is executed. So here you have a Boolean expression, and within the Boolean expression, if the Boolean expression is true, then the body of the if statement will be executed. If it is false, then the body of the else will be executed. So in this case, you have both sides of the situation or both sides of the condition being executed. So let's look at an example here where we try to find the maximum between two numbers. So in finding the maximum between two numbers, it means we would need two integers. So int num1, int num2. Then because we are going to be finding the maximum of these two numbers, we will first of all request for these numbers to be entered through the keyboard. And that is where we use the output function printf, enter two numbers. Then scanf will give us the opportunity to get these numbers read or inputted into the code. Now, you would also realize again that the if statement has a certain Boolean expression, that is num1 greater than num2. This is a relational operator being used here. So if num1 greater than num2, then print on the screen that the first number is maximum. However, if it checks the Boolean expression and it is false, then it means that the second number rather is what? Maximum. So this is a basic explanation or an example of how to use the if-else statement. How to use the if-else statement. Now, how do we look at situations where there are several tasks that needs to be performed? Both sides of the Boolean expression is met. However, there are several tasks that needs to be performed. So for example, you decide that if you get $1,500, then you probably get a Microsoft Surface. Else, if you don't get the 5,500 and you get 1,200, you would go and buy a MacBook Air. Or if you don't get the 1,200 and you get 1,000, you would buy an HP Ultrabook. However, if you are not able to make this target, then you would go for any mid-level computer or laptop. So in this case, you cannot execute such number of tasks with just an if statement or an if-else statement, but rather you use the if-else-if statement, which we also term as the ladder if-else-if statement. So in this scenario, what will happen is that there is a parent condition, and then the other tasks or scenarios will be dependent on the parent condition. If the parent condition executes to be true, then it means the other ones would not execute. So like I said, this is the situation where you use a combination of the if-else-if statement. And basically, the if-else-if statement is an extension of the if-else statement. It specifies that if a certain condition is true, then execute a task. However, if that condition is not true and another condition is true, execute that task. Or if some other condition is true, execute that task. And then if none of the conditions are true, you execute a default task. So that is basically how the if-else-if statement behaves. So in this case, this is just an illustration of the if-else-if statement syntax or syntax. So you would see that if Boolean expression 1 is true, then execute the body of if and skip the other ones. However, if that Boolean expression in the if is not true, check else if Boolean expression 2 is true. If that is true, you execute it and skip the others. If that is also false, then it means you would have to check Boolean expression n, that is having gone through several of these expressions, and execute that. If that is also not true, then you would execute the final expression if none of the expressions are true. In this case, all the expressions are skipped. So you take note of that. Any questions so far? We have done about 40-something minutes of talking. Don, do you have any question? Are you following? All right. Now, let's look at the illustration of the if-else-if statement with the use of a flowchart. Now, here, you have a Boolean expression 1. So if Boolean expression 1 is true, then it means you are not going to look at Boolean expression 2 and the nth Boolean expression. However, if Boolean expression 1 is not true, that is when the flow of execution moves to Boolean expression 2. Check Boolean expression 2. If that is true, the body of that Boolean expression or the body of that if is executed. If that is false, then we'll go to the nth Boolean expression. If that expression executes to be true, then the body of that if will be executed. If it is false, however, then the body of the else statement will be executed. So this is basically a PDF, sorry, a flowchart illustration of the if-else-if state. Let's look at an example of a code which is used to execute the if-else-if statement. So here we have a code that is used to check either negative, 0, or positive. So here, since we are looking at negative, 0, or positive, what it means is that we would have some integers. So we declare our variable or our integer variable, and then we request an integer entered through the keyboard. And since we have 3 conditions to check here to see if the integer is positive, negative, or 0, the first if with a Boolean expression num less than 0, if that is true, then it means that our integer is negative. So that will be executed. However, if that is false, then it means it is either positive or a 0. So else, if the num or the integer is equal to 0, then we would say the number is 0. However, if it is not a negative and it is not a 0, then automatically it will be what? A positive. So else number is positive. So that is what happens. So kindly take note of that. That is the if-else-if statement. Kindly take note of that. Now, let's look at something we call the nested if-else statement. The nested if-else statement. The nested if-else statement. The simple if and if-else-if statements provide some level of control for program flow that we cannot dispute. The single or the simple if statement allows us to execute based on a single condition. That is, if the condition is true, we go ahead and then execute, or the code executes a certain statement or performs a certain task. Then if-else-if provides the option to look at multiple conditions. That is, if one condition is false, you look at the other condition and then try to execute that condition. If the other conditions are all false, then you resort to the default task and perform the default task. So that is basically how it is. All right. So let's consider a situation where you want to execute a statement based on multiple levels of condition check. For example, at the airport, you would normally have multiple levels of checking before onboarding is done. You first of all would normally go through the basic security check. Then your ticket is checked. If you have a valid ticket, then you go for your passport to be checked. And if the passport is valid, then again, you would go for security check finally. And once this is considered completed, then you can board the airplane. Otherwise, depending on what the situation is, some action is taken. Now, just as the if-else if statement is able to control multiple conditions, the nested if-else statement has the ability to control program flow based on multiple levels of conditions. Now, let's look at the situation here. So, in explaining the syntax, if you look at the Boolean expression here, you would realize that an if-else statement has been embedded in another if-else statement. So if Boolean expression 1 is true, then we now come to check the if nested expression to see if that is also true. So if Boolean expression 1 and and the nested expression 1 are all true, that is when the body of the if is executed. Else, if Boolean expression 1 is true, but the nested expression is false, then it is executed. Else, you have another nested expression within the if-else statement. So this is how the syntax is written. Now let's explain this with the help of a flowchart. So you have Boolean expression 1. And once the Boolean expression 1 is true, then body of if would take control over the execution. And then the nested expression is now looked at. If the nested expression is also true, then the body of if is executed. But if it is else, if it is false, then the body of the else is executed. Similarly, if the Boolean expression 1 is not true and it is false, then the nested expression, which is attributed to the else of the original if else, is now considered. And in the same vein, if the nested expression 2 is true, then the body of if is executed. Else, if it is false, then the body of the else is also executed. So let's look at an example of a code that is being used to explain this example or this nested if else statement. So this is a program to find maximum between three numbers. So if we're looking at three numbers, it means we're going to have three variables. So int num1, num2, num3. If you remember, we said that once all these variables have the same data type, there is no need to write the data type or declare the data type for each and every one of them separately. You can just declare with just one data type casting for all the variables. So in this case, integer or int num1, num2, num3. And then because we're going to need these inputs, we request for the numbers using the printf function, and then the scanf helps us to get the numbers into the code. So now pay attention here. You would see that in this line of code, you have an if else statement. And then under the if, there is another if else. And then under the else, you have another if else. Now, if num1 is greater than num2, that is if it is true, then we will check if num1 is also greater than num3. And if that is also true, what it means is that num1 is the maximum number. However, if num1 is greater than num2 and num1 is not greater than num3, then we can say that num3 is the maximum number. However, if num1 is not greater than num2, then the else section of the code would now be executed. In that case, what is going to happen is that it will check the Boolean expression for the second nested, or it will check the second nested Boolean expression. So here it will check if num2 is greater than num3. If that is the case, then num2 is the maximum. If that is not true, then num2 is the maximum. If that is not the case, then num3 is considered the maximum. This is a bit tricky. Do you understand what I'm explaining here? Hello? Okay. Someone's hand is up.
Lisa, can you go?
Joe's. Okay. Now, let's go back to the flow chart. In the nested if else statement, we don't necessarily base our execution on one condition. It is based on several conditions. So we have an if else statement. So when you look at this flowchart, the branches of the Boolean expression 1 gives us the opportunity to execute a normal if else. So if it is true, the body of the if will be executed. And then if it is false, the body of the else will be executed. Now you would see that within the body of the if, another Boolean expression has been embedded, which is also an if-else statement. That is what we call a nested if-else statement. Then within the body of the else as well, another Boolean expression or an if-else statement has been nested in there, has been given the opportunity to sit in there. So if Boolean expression 1 is true, then the body of that if statement will be executed. But before it gets executed, it will also check the Boolean expression for the nested if-else statement within it to see if it is true. If it is true, then it will execute the body of the if of the nested statement. If it is false, it will execute the body of the else of the nested if-else statement. Now, that is for the body of the if of this program itself. Now, when we move on to when the Boolean expression 1 is false, that is when we are looking at the else side, which also has another nested if-else statement in there. So with that one, we would have, if it is true, the body of the nested or the if of that nested if-else statement is executed. And then if it is false, the other side is executed. So now let's illustrate this with the help of a program or a code, an example of a code. So you have 3 numbers and you want to check which of these numbers is maximum. So like we knew, or like we looked at earlier on, we said that we would have to declare our variables anytime we are writing our codes. We are already familiar with the preprocessor declaration. So in declaring our variables, since these are integer variables, we precede them with int num1, num2, num3, which gives us these variables. Now, printf within the code, which is line 13, allows us to enter, or it prints on the screen and requests that we enter 3 integers. So once we enter that, scanf would now take them as inputs into our code. And then from there, we will start with our execution of this control statement, which is the nested if else. So here you see that you have if num1 greater than num2. Here we are using relational operator, greater than. If that statement is true, after entering the integers, then it will go ahead to look at the if-else statement within that if statement to see if num1 is also greater than num3. If that is the case, or if that is executed to be true, then we can say that num1 is the maximum number or the maximum integer. But if that is not true, then what it means is that num1 is greater than num2, but num3 is the maximum because num1 is not greater than num2. Now, if none of these if-else that has been embedded in the if statement is being executed because the first if with the Boolean expression num1 greater than num3 is false, then the code would come to execute the else section of the main if-else. So there it will look at if num2 is greater than num3, then we would say that num2 is maximum because num1 is not greater than num2. However, if num2 is less than num3 and num1 is less than num2, then we can say that num3 is the maximum. So that returns, and then that is the end of the code. So this is how we use the nested if statement in C programming. Is it clear now? Okay. Now the next thing we would be looking at with the conditional statements or decision statements, or the next example for decision statements is the switch case statement in C. The switch case statement. So the if-else statement provides support to control the flow of a program. It makes decisions based on certain conditions. And then it would select an action or a task to be performed if a certain condition or some condition is met. Now, in instances where you would have to take decision based on available choices, so you go to a supermarket or an electronic shop, or you walk into Telefonica and you want to buy a laptop, and you would have to select from different modules, or you go to a restaurant to eat. And then you have several choices on the menu, which you would have to select from. In this case, the choices are fixed. They are in the menu, they are written there. So in this case, the only condition that would make you make a choice is your pocket. But the choices themselves are fixed. So that is when we use switch case. Now, switch case statement gives us the ability to make decisions from fixed available choices, rather than making decisions based on conditions. So using switch case, we can write a more clean and optimal code that takes decisions from available choices. So let's look at the syntax for switch case. So in this case, we have the switch expression, then case 1, the case statement. Then you break case 2, the case statement, case n, case statement. Then there is a default statement when we are not able to pick any of these cases. So let's look at an illustration or rules for working with switch case. Expressions inside the switch case must evaluate to integer, character, or an enumeration constant. Switch case only works with integer, character, or enumeration constant. So it means that the switch case should always evaluate to an integer, which would be true. Now, the case keyword, remember when we looked at keywords, case is one of the 32 keywords or reserved words that we looked at. This keyword must follow one constant of type evaluated by expression. The case along with a constant value is known as what? The switch label. You can have any number of cases. Each and every case must be distinct from the other. For example, it is illegal to write 2 cases and label them case 1. If there are 2, you can have case 1 and case 2. You are free to put cases in any order. However, it is recommended to put them in an ascending order. It increases program readability. You can have any number of statements for a specific case. The break statement is optimal. It transfers the program flow outside of the switch case. So if you look at the syntax here, you would see that there is a break after every switch statement. So if we are not executing the statement of case 1, then it means we are breaking away from case 1 and then we're moving to case 2, like that. Break statement is covered separately in this C lecture, which we'll look at as we progress. The default case is optional. It works like an else block. If no cases are matched, then the control is transferred to the default case. So you would see that the last one is default. When any of these cases is not met, then the flow of execution will be transferred to the default to execute. So take note of that. Now let's look at working with the switch case statement. We have an integer which is num. So int num equals to 2. And we want to use the switch case. So switch num, case 1, printf I am 1. Break, case 2, printf I am 2. Break, case 3, printf I am 3. Break, printf I am an integer, but definitely I am not 1, 2, and 3. Let's look at how this is executed with the use of a flowchart. So you have your switch expression where you have switch into brackets the variable, then case 1. If case 1 is yes, then the statement of case 1 is executed, and then we end the switch. If it is no, then it breaks to case 2. If case 2 is yes, it executes statement 2 and then ends the switch. If case 2 is no, then it will go to the nth case and then execute the nth statement if that is yes, and then the switch is ended. However, if all the cases are no, case 1 no, case 2 no, case n no, then by default, a default statement would be executed. So this is how the switch case statement is illustrated. So let's see an example where the switch case has been used. This is a C program to print the day of the week. The integer here is week. Enter week number 1 to 7. So depending on which of the numbers is entered, case 1, if week is equals to 1, print it's Monday. Case 2, it'll print it's Tuesday. If it is not 2, it'll print it's Wednesday. It goes on like that. So you see case 1, Monday, case 2, Tuesday, case 3, Wednesday, case 4, Thursday, case 5, Friday, case 6, Saturday, case 7, Sunday. However, if it doesn't meet any of these cases, then it will go to the default to ask to enter week number between 1 and 7, because none of these cases have been executed. So basically, this is how the switch case is executed. Now, just as we looked at the nested if-else statement, we also have the nesting of switch case, where you can have a switch case within another switch case. So when you look at this here, you have a switch and a default at the bottom. Then you have case 1. Then we have case 2. Within case 2, there is another switch, case 1, case 2, and then the nth case before we get our nth case for the original switch case. So just as we looked at the nested if-else statement, you can also have nested switch case statement. However, it is not recommended to put one case inside another. It is not recommended to put one case inside another case. What that does is that it ends up making the readability of your code very complex. So when you look at the instruction here or the syntax that has been used as an example, you will realize that because of the nesting of another switch case within another case, the code readability becomes somehow. Now, let's look at the if-else, if versus switch case. Their differences and usage. If-else, if, and switch case. Both of these can take decisions based on certain conditions. Both are almost similar in nature. However, there is always a debate as to which one to use and which one not to use and when to use it. Let's look at the working mechanism. The if-else, if checks all conditions sequentially until conditions match. It skips all subsequent condition check once a condition is matched. But on the other hand, the switch case does not do that. It does that differently. During the compilation, however, during the process of compilation, what happens is that a lookup table based on the case values is created. So for instance, when we looked at the code with Monday, Tuesday, Wednesday, Thursday, Friday, an integer variable has been set, which is the week. And that has been defined to be between 1 and 7. So what this does is that automatically it creates a lookup table during the compilation of the code. And on execution, instead of matching the switch expressions for each case, it queries the lookup table rather, which was generated during the compilation. So depending on, for example, the example we looked at with the weeks, once the integer matches a certain day of the week, it rather looks at it at the lookup table and then matches them. So if the case exists in the lookup table, then it transfers control directly to that case. Otherwise, the default case would take execution. Now let's look at performance in terms of the usage of switch case. When we compare the if, else, if, and the switch case has a better performance, like I explained earlier on, because of the lookup table and its ability to transfer the control of the program to the matching case or the default case. Whereas for the if, else, or the if statement, all the conditions are checked sequentially, and this in a way downgrades the performance when you compare it to the switch case. Now, even though the switch case has good performance, it is not always true for every program. When we use the if, else, if, we generate a more readable code with fewer conditions. If we're looking at an if, else, if statement where we're looking at only 5 conditions, it would perform better than a switch case where we're looking at 5 cases. That is, it is easier, or it is more okay to check conditions that are few compared to querying a lookup table. Now, let's look at it from this angle. Assuming a telephone directory has 5 names printed on 5 separate pages. What is the most efficient way to search for a name in the directory? 1. Searching directly in each page of directory, one after the other. 2. Creating an index page where there is also the search, you search the name in the index page, and if the name exists in the index page, then you go to the particular page. So based on this, we can conclude that even though the switch case in some cases gives us better performance, the if, else, if statements generate better performance with fewer conditions. However, the switch case also gives us better performance when you have fixed number of choices. That is when your choices are fixed. Now let's look at the complexity. Depending on the situation, the if, else, if, as well as the switch case can be simple or complex. Now, if the conditions increase or if there are a lot of conditions, then the if can be very complex. For example, in instances where we have to do the nested or the nesting of an if else in another if else, this increases the complexity of a code. Compared to that, the switch case is easy to read. It's easy to maintain the code, but it can be confusing when we try to implement the nested or the nesting of switch cases. That is where the complexity comes in. So they all have their good sides and bad sides depending on how you would want to apply them. So you kindly take note of that. And that is it about their complexities. Now let's look at the limitations of switch case. The switch case has a certain limitation which cannot be unseen. Switch case works only with integer, character, and enumeration constants. So the case label must follow a constant, and it does not work with variables and expressions. So that is a limitation, or these are limitations of the switch case. And when we write codes using the switch case, whatever code we can use the switch case or we can write in the switch case, we can transform it to an if-else if statement. But if you have an if-else if statement, you cannot convert it into a switch case, at least not in all cases. So take note of these as well. So when we compare the switch case and then the if-else if statement, the if-else if statement uses conditions instead of list of choices. And it is better used when there are few number of conditions. Whereas for the switch case, you would have to make a decision based on choices. And these choices can only be in the form of an integer, a character, or an enumeration constant. So that is it for decision statements. So in today's lecture, we have looked at the simple if statement. We have looked at the if-else statement. We have also looked at the if-else if statement. And then we have looked at the nested if-else statement. And then we have also looked at the switch case statement. Now, remember we said there are three categories of control statements. That is the decision statements, which is also termed as the condition statement or relational statement. And then we have the looping statement. And we also have the jumping or the jump statement. So today's class, we have looked at an introduction of all these three categories, and we have gone into details to explain the decision statements. In our next class, we will look at the looping statements and the jumping statements. So this brings us to the end of today's class.